Hi, I'm Dr. Christopher Sutton. Welcome to my Introduction to GIS video series. In this video, I will discuss how to write latitude and longitude coordinates. While my students tend to understand latitude and longitude, the written form of the coordinates can be confusing. So let's take a look at how we write latitude and longitude coordinates. There are two major formats for writing latitude and longitude coordinates. The first is DMS, which stands for degrees, minutes, and seconds. DMS is a sexagesimal system, meaning it's based on the number 60. In this system, there are 360 degrees in a circle, 60 minutes in a degree, and 60 seconds in a minute. As you will recall from an earlier video, latitude ranges from 0 degrees at the equator to 90 degrees at each pole, while longitude ranges from 0 degrees at the prime meridian to 180 degrees on the opposite side of the planet. When writing DMS coordinates, there are several important conventions to keep in mind. First, latitude is always listed before longitude. Second, we indicate the hemisphere of the coordinate position using letters, N or S for latitudes that are north or south of the equator, and E or W for longitudes that are east or west of the prime meridian. Third, specific symbols indicate degrees, minutes, and seconds. The degree symbol is used for degrees. A single straight mark represents minutes, or more precisely, arc minutes, and a double straight mark represents seconds, or arc seconds. Here's something to be mindful of. The single and double straight marks used for minutes and seconds are different from the curved apostrophes and quotation marks that word processing software typically inserts. Always use straight marks when writing coordinates, not curved ones. The second format for writing coordinate values is decimal degrees, or DD. Decimal degrees differ from DMS in several important ways. First, the order is reversed. Longitude is listed before latitude in decimal degrees, which is the opposite of DMS. Second, we do not use letters to indicate hemispheres. Instead, we use positive or negative numbers. For latitude, locations south of the equator are assigned negative values. For longitude, locations west of the prime meridian are also assigned negative values. Coordinates in the United States, for example, use negative longitude values because the country is in the western hemisphere, and positive latitude values because it is in the northern hemisphere. In decimal degrees, only the degree symbol is used, no minutes or seconds symbols. GIS software uses decimal degrees internally, although coordinates can be displayed in either format. Why does GIS software prefer decimal degrees? There are several practical reasons. The first is mathematical simplicity. Calculations, transformations, and spatial analyses are much easier with decimal numbers than with the sexagesimal DMS system. Whether you're converting between coordinate systems or performing geometric operations, everything works more efficiently with decimals. The second reason is database efficiency. GIS databases can store decimal degrees as simple floating point numbers, which require less storage space and enables faster queries compared to storing 3 separate fields for degrees, minutes, and seconds. The third reason is programming convenience. Most programming languages and mathematical functions expect decimal input. Working with 40.4461 degrees is straightforward, while 40 degrees 26 minutes 46 seconds requires additional parsing and conversion steps. The fourth reason is precision control. Decimal degrees allow easy precision adjustment by simply changing the number of decimal places, whereas DMS precision depends on subdividing seconds. The final reason is international standardization. Most modern mapping standards and web services like Google Maps, OpenStreetMap, and GPS devices default to decimal degrees. Let's walk through the process of converting DMS coordinates to decimal degrees. Here we have the McDonough County Courthouse located in western Illinois. The conversion formula is straightforward. A decimal degree equals the degrees plus the minutes divided by 60 plus the seconds divided by 3,600. Why these numbers? Because there are 60 minutes in a degree and 60 seconds in a minute. Therefore, each degree contains 60 minutes and 60 times 60 or 3,600 seconds. The coordinate position for the courthouse is a latitude of 40 degrees, 27 minutes, 31.68 seconds north, and a longitude of 90 degrees, 40 minutes, 16.32 seconds west. Let's convert these coordinates to decimal degrees. We'll start with latitude. 40 degrees plus 27 minutes divided by 60 plus 31.68 seconds divided by 3,600. This gives us 40 plus 0.45 plus 0.0088, which equals 40.4588 degrees. Because the building is in the northern hemisphere, this value is positive. Now for longitude. 90 degrees plus 40 minutes divided by 60 plus 16.32 seconds divided by 3,600. This gives us 90 plus 0.67 plus 0.0045, which equals 90.6745 degrees. Because the courthouse is in the western hemisphere, this value is negative. Remember that in decimal degrees, longitude is written before latitude, so the complete decimal degree coordinate position is minus 90.6745, 40.4588. In the remaining videos in this unit, I will cover coordinate systems that do not use angular measurement. They are projected coordinate systems.